What did I do as I ended class yesterday? First of all, what did I have at the very beginning of this problem? I had a polynomial, specifically a quadratic, right? Did anybody even think about u sub? Like straight from the very beginning, not like arctangent u sub, where it has to fit a certain formula, but just go for u. Who would we have gone for if we had gone for u right away? Good, x squared minus 6x plus 13. But what would we have had for du? Do we have anything to help us? No. We have no x terms, we have no constants. And some of you guys might be like, okay, well, no big deal. But the problem is, if we had gone plugging in with that as a u and this as a du, do you guys realize we would have had to go to this u expression, solve for x, and then plug it in a denominator? Do you see what I mean? Like, it's not a good integration on crack, and it's not a possible one. If we're putting a mess in a denominator, oh, we're in trouble. So that's something that, because remember, on this test, these problems, even on the review, these problems will be mixed up, right? So you're going to have u sub ones where you're supposed to choose u as the entire denominator. But do you see how if you had tried to do 1 over u go to ln or negative 1 over u ln, you would have had to do some crazy substitution, and it would not have gotten you any closer to an exact rule. Janelle? No, there might be. There might be a hint on one. You know what I mean? But otherwise, it's going to be mixed up. But it's okay. What did you just get? Practice test where it's all mixed. And then your test review, I think your test review is at least somewhat mixed as well. So it's a good practice. Does that make sense? And the nice thing is we're going to try to start reviewing today and get you guys actually playing around and working. Then you have a 3-day weekend. Then Tuesday, we'll go over questions on the test review. Ooh. What else do we have this chapter that we haven't been quizzed on yet? But only 3. Not the like 10 or 9 or whatever from last chapter. Only 3. It was the derivatives of logarithmic, or with ln. Ln's not inside, ln's in the answer, which had to do with the integral of 1 over u du, the integral of tangent of u, the integral of cotangent of u, the integral of secant of u, and the integral of cosecant of u. The 4 trig functions that we hadn't seen alone in an integral before, and then 1 over u. The ln one, that's one. Then the e to the u, b to the u card, that's another. And then inverse trig. 3 cards, all just rules. Can we do this? Forever Quiz Tuesday. Okay? If you want to, grab out your phone really quickly, because some of you always forget and are like studying as you walk in because you haven't studied. I don't mind if you grab out your phone like, Forever Quiz. Okay, Forever Quiz Tuesday when you walk in. But besides the Forever Quiz, going over the test questions, and then with extra in class, letting you guys play with the practice tests some more practice tests, due as always on the day of the test, Wednesday. Any logistic questions? Are we okay? Okay. Yeah. 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 No. That's okay. That's okay. We're good? Okay, so coming back. The u sub was a mess. So then we think outside the box. And guys, this is going to be a very common, whether it's alone on the outside, hoping to get to arctangent, whether there's a square root and it's underneath and we're hoping to get to arcsine or arcsecant. Completing the square is going to be necessary here and there, or it was in your homework and it will be on your test review, practice test, etc. Here and there, okay? So how did I get the 9? Because this one I got first. How did I get that 9? Okay. I thought about this separately and said, let's take the x terms and let's take the constant, because the 13 is not going to cut it. Even if I did the x method, even if it did factor, I need a square for arctangent or arcsine or arcsecant. So to get a square, oh my goodness, Algebra 1 applied. To get a square, Ali, you're saying it really well. He's saying to take the middle term, the -6 technically, to divide it by 2, and then to square it. Complete the square, take the middle term, divide it by 2, and square it. It's a shortcut for how we would, x minus 3, how we would square a binomial. When I taught Algebra 1, I said, forget it, don't memorize the shortcut, just do x minus 3 times x minus 3, go. You'll keep yourself honest, you'll keep yourself safe. But the shortcut actually says square the first, square the last, multiply the 2 insides, and multiply them by 2. That's technically the shortcut to a perfect square trinomial. You square the first, square the last, and double the inside. So what we're doing is saying, hey, the inside is double of what? Cut in half, and then square it. Cut in half, and then square it. But what we do on the inside, we can't go adding 9 to the other side because there is no other side. We instead need to look at this expression and say, I need this to stay balanced. In chemistry, you stay balanced. In math, you stay balanced. In algebra and algebraic expressions, you stay balanced. So if I add 9, what am I doing over here? Does anybody remember we have to be careful to look on the outside just in case? Because what if we had factored out a 2 or a 4 or a 9 already and then we put a plus 9? Would it really only be a plus 9? But this one, good, but this one is just 9. So what we added in here, we double checked, or you should double check. It was just plus 9 in the greater context, so minus 9 will offset. Then I go ahead and say, oh, sweet, that's 4. And oh, sweet, I can factor him. And now, how do you finish the problem? Did anybody keep going? Any group keep going? Who's your you? Yeah, it is, because you guys are starting to learn your arctangent formula. Who's your du? dx. Oh, and by the way, what didn't I consider? Who's your a? Got it. So could we rewrite this as negative 1 over u squared plus a squared? Hey, it's just du. Yeah, we can. So who is this guy? Yeah, it's arctan or tangent inverse. I need a negative. Wait a minute, how does the rule go for arctangent? Good, 1 over a, so 1 over 2 arctan, or I'm just lazy, so tangent inverse of u. X minus 3 all over a plus c. Dun, 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 dun. Did I mention this to period 1 yesterday? Has any of you, have any of you thought about where the arc cosine formula is, or the arc cosecant formula, or the arc cotangent? Did we talk about this yesterday? I don't think so. It was period 6. Where's the arc cosine, arc cosecant, arc cotangent formulas? There were 6 inverse trig functions for derivatives. Wait a minute. Wasn't arc cosine the exact same thing as arc sine, but with a negative? Wasn't arc cosecant the exact same thing as arc secant, except with a negative? Wasn't arc cotangent the same thing as arc tangent, just with a negative? Ah. Well then, couldn't we technically, if there's a negative, call this arc cotangent? Yes, but the nice thing is, in all of the calculus and the AP exams, guess what I've seen? They only go backwards. They only anti-derive to arc tangent, arc secant, and arc sine, which is why you only have 3 formulas on that card instead of what could be there, which is so. Be thankful and just say whatever. If there's a negative, I'm just going to write a negative. Is that cool? Okay. So, last problem in our notes before we go grade. Do you guys have your homework spirals open? Can you go ahead and get your homework spirals open with a colored pen? I'm going to ask you in just 1 second if number 41 was an actual homework problem. I don't think it was. I think it might have just been an example. Okay. I think it was just an example to help out if we had all this extra time, which we never have. Not your fault, not your fault. Just some years we have it because the classes go fast. Whether or not they totally get it, they just go faster. But we're good, don't worry. We talk about life. We're period 1. Who do you guys think U is? What is it? X under the square root? So just X or square root of X, AJ? I'm just clarifying which one. Huh. Does anybody else agree with that? Square root of X?
I agree.
Wow. Was anybody thinking X plus 1? Okay. If we had tried X plus 1, do you guys see how, just a hypothetical? Because I think that's what my brain would originally think, like without further experience, etc. If we had tried U equals X plus 1, du would equal dux, right? You guys see that we would have had to do something there, yeah? So then we would have done X is equal to U minus 1. So we could have had the square root of U minus 1 times U with... Does that look any better? Or did it just kind of get worse? Okay, so I'm not saying that your brain thinking X plus 1 is bad, because it's not. Because usually if we see parentheses in the denominator, yeah, we totally go for that. But AJ and LA both are saying, let's make u square root of x. What would du be? Is that okay? Bring down the 1/2, negative 1/2 power 1 over 2 square root of x. How would we plug this in? Do you think that should be your u? It's actually not. I actually really want to keep that guy. Because I really want to have him cancel out with that guy. So how on earth do I get u's in here? Isn't x the square of square root of x? Pause. Isn't x the square of square root of x? Oh, this was an arctangent? Now, is this messy? Is this nasty? Is this gross? Yeah. No, it is. Why is it so hard? Because he doesn't look like a square. But guys, this just kind of reveals the fact that anything can have a square root. So technically what I want to be thinking of is a is equal to 1. The square root. Oh. The square root. I'm going to be just fine. As long as I keep it legal. I'm going to be just fine. But was it hidden? Oh, yeah. Wait a minute. This is not good. This is not good. It's a definite integral, right? So I have to say 4x is within 1 to 3. It's up to you guys. Do you want to go u bounds or you just want to keep it in x's? I don't care. Either one. Keep it in x's. Okay. So then I can go ahead and do, wait guys, can't I go straight to arctan now? So 2 is going to come on the outside. I have 1 over u squared plus, can't I make this a squared? Okay, so I have 1 over a, which is 1 over 1 times tangent inverse of u over a. U is square root of x because we're going back to x's anyway. And we're going from 1 to 3. How we doing, cool kids? 2 is the extra coefficient. 1 over a tangent inverse of u over a from 1 to 3. And I plugged back in my x's because you guys said go with the x's. And I agree. I think that's easiest. So now I can say 2 times tangent inverse f of b minus f of a, square root of 3, minus tangent inverse of 1. Whew, that was a hard problem. There's no way the AP would simplify. Yeah, they would. Why? What am I singing? Ooh, teeter chart. Isn't this the pi over 6, pi over 4, and pi over 3? I think we have the whole sine is 1, 2, 3, 0, 1. Tangent is 0, and then it's undefined. We could keep going with 0 and pi over 2, blah, blah, blah. But I kind of tune in on this a lot because tangent is the guy I don't know so well. Sines and cosines, 1 root 2 over 2, root 3 over 2. I know those ones pretty well. But tangent, square root of 3. Hey, when's tangent root 3? When's tangent 1? They're not going to leave it like that. Come on, it's unit circle. So therefore I have pi over 3. Whoops, I don't know what I was writing. Just shh. Apologies. Pi over 3 minus pi over 4. Oh, they're bound to be done now. Common denominators. Can't we make that 4 pi over 12? And can't we make this 3 pi over 12? Which ends up being 1 pi over 12 times 2 over 1, which is 1 pi over 6. Now we're dun 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 dun. Michael's face right now, it's perfect. All right. What have I been saying all year? And I was saying all year last year as soon as we covered trig. You need to know your. Let's go grade. Let's go grade. The final homework section of this chapter before the review. Uh-oh. Where are my evens? Hold on. Oh, that's so weird. Where are my evens? Okay, this is the first. I'm sorry, guys. They disappeared somewhere. Okay, we'll go find them. That is so weird. And it's live. It's not like it lost connection. All right, cool kids. You got to keep me honest. We're going to go find our evens because they're missing. Aw, sad day. Actually, no, pause. Pause. I don't want to waste your time. You guys go ahead and collaborate really quickly on the odds. You could grade them, you could check them, you could CalcChat them. I want you guys to talk really quickly. Does anybody have any questions on the odds? Yeah? Okay, ready, set, go. I'll go steal my evens. Full for some. Okay, grading the evens. Number 6, final answer should have been 1/2 arctan of x minus 3 over 2 plus c. Arctan or tan inverse, both are fine. Number 14, did you guys realize u was cosine and a was, oh, no, they gave us a 7. That's okay. What's the square root of 7? Root 7. Okay. It's all right. It's all right. Everything has a square root. Well, anything positive has a square root. Now, they rationalized it. I don't know. Maybe the AP would have rationalized it. I think the AP would have left it like this. But careful, there is a negative. It's barely there. Sorry. There's a little baby white space. There's a negative in front. Number 24, final answer. Ooh, hoo, hoo, hoo. Look at you having to do unit circle with secants. Hold on. How could you do unit circle with secants? Secants are 1 over who? Cosine. Cosine. Isn't that? 1, 2, 3, 1. Okay, that's cosine, right? So who would secant be? Wouldn't he be the reciprocal of everybody? So wouldn't secant be 1, 2 over rad 3, 2 over rad 2, and 2? And wait a minute, that's weird. Okay, then simplify him. So it'd be 2 rad 2 all over 2. Oh, wait a minute, that's just rad 2. Wait, he's weird. Simplify him. Okay, 2 rad 3 over 3. Oh my goodness. So when they said arcsecant of 2, I should have been able to pi over 3. When they said arcsecant of 2 rad 3 over 3, I should have been able to go to pi over 6. Yes. Unit circle. Some of you might need to be like, oh, that cheater chart, I think it's helpful. Because it is. Number 40. Whew. What did you need? Come on. What'd you need? Completing this square. But there wasn't. Well, then you add what you need. Adding the 1 gets you x minus 1 quantity squared. And if you add the 1 to perfect or to complete your trinomial, your perfect square trinomial, you had to subtract 1 on the outside. Wait a minute. Minus 1. Oh, yeah, that's the formula. U squared minus u. U squared minus u. I think. Oh, no, we have one more. Number 74, the final answer is D, as in delta, or duec, or do it. Anyway, what questions do we have that we still need to go over? I'm ready. Oh, we were asking about 40 or 39? 31, AJ. 17? 39. Let's start there, and then if we have more time, we'll do more. I don't mind. Let's start with 17 because it was the newest, not the newest. Sorry. The closest. Okay, number 17. Oh, ho, ho. Am I in the right section? No, I'm not. That was an improper fraction. You should divide. Okay. Number 17. Now I see it. Oh, not an improper fraction. No, we shouldn't divide. But why am I going to say split up? Split up. Huh. We'll get back to it. After number 17, I think 31 was the next one. Is that right? Okay. Oh, there he is. Ooh, he's a good one. Oh, do I still have that problem on the front board? No, I don't. My front board is nice and clean. I just wrote on it. Okay. Do you guys remember how I had that logarithmic one on the board yesterday? How we made u ln? Do you remember that? It was ln over x, and we made u the ln. Huh. I see an inverse sign inside an integral. That's not supposed to be there. Inverse sign only happens outside the integral. Interesting. The other question was number 39? Yes. Got it. Complete the square? Ooh, but with a negative by the squared term. All right, let's see what we can do on these three. Number 17, does anybody have a place where I should start? Does anybody have a place where I should start on number 17? Separating. Why? I don't mind the x squared plus 1 with a constant to be an arctan. That's an arctan. But I don't want an x up there for arctan. So what does that mean? Well, maybe the x should be on his own? Am I allowed to divide? Yeah. And why is that helpful? Well, this one, guys, if you notice, u squared plus a squared, it's already ready to be -3 tangent inverse of x plus c, just by going quickly with my u sub with a's, etc. But what do I do with this guy? Shouldn't I say that u is equal to x squared plus 1? Shouldn't I go du is equal to 2x dx? Guys, it's a good old-fashioned 1 over u du. Now, careful, you have to divide by 2x. Divide by 2x. But when I go to plug in on this side, I would have the integral of, pull out your 1/2, x over u times du over x. Maybe part of it is arctangent and the other part is a good old-fashioned ln. So if you guys were looking at your answers for this one, you should have seen an ln and an arctan. Because if you take the integral of 1 over u, that's going to be, well, 1/2 ln of u, x squared plus 1. And then I have this piece that needs to come down, minus 3 tangent inverse. The only other thing I can think of, I guess you could bring that 1/2 up. The absolute value is redundant because that's always positive anyway. So I guess we could have rewritten it like that by bringing the 1/2 power up, -3. How are we looking? We looking good? Questions? Split it up. This one, though, number 31, it's a lot like that problem on the board yesterday. I don't know what to do with an arc sine in an integral if he's not the u. Same way I don't know what to do with an ln in an integral if he's not the u, and I haven't taken Calc BC yet and learned integration by parts. So, why on earth would I make arc sine the u? Because there's no rule with him in the inside. And the derivative of arc sine is, oh my goodness. I can rewrite this pretty quickly after doing some u sub as u du. Well, I don't mind that at all. Do you? Do you? Anyway, just kidding. Isn't that just 1/2 u squared? And who is u? And aren't I doing it from x bounds of... If you guys don't like this guy, can't you rationalize him and see what other form he takes? So it's going to be 1/2 times arc sine of square root of 2 over 2 squared minus arc sine of 0 squared. Yep. Isn't that going to be a pi over 4, and a pi over 4 is squared is going to be a pi squared over 16 minus, and isn't sine 0 at 0? Oh, nice. Times 1/2. I do believe you get pi squared over 32, but I would love some affirmation. Good. And then last one. Questions on that one first, though, as I get ready for next one. Are we okay? What's a note that you could make in a color pen, highlighter, etc., being like, hey, ding, 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 for the test? If you see an ln inside, if you see an arc trig inside, what should you make u? Does that make sense? Cool. Ooh. What do you guys see? Some of you guys are like, complete the square. Ah! I heard split up. How many of your brains went straight to arc sine, or arc secant, or arc something with a square root? How many of your brains considered u sub for at least a second? Okay. I just wanted to know how we went. How many of you guys are thinking split up first? Okay. So if we do u sub first, what's du? How close are we to that? Couldn't we rewrite this as, are we allowed to pull out a negative and move it up? Sure. How close are we now? Oh, so close. We have options. One way is you could have split up this guy right away from the beginning, saying, hey, a variable with a variable, I bet that helps. And you could have put the -3 over here. Non-variable with, I bet that's going to be an arc trig, and you could have thrown that in an integral. You could have separated two, but whatever. But then if you looked at this, you're like, he's missing a -4. We could have actually subtracted a 4 and added a 4. That's one way. Or up here, you could have subtracted a 1 and added a 1, and then separated that guy off to the side. Why? I like that for him. So I could go ahead and say, hey, dx, and I'm going to go ahead and take this work and be like, you are so great for... Just kidding. You are so great for him. Perfect. But what about him? Inverse sine. Inverse sine, after some completing the square. So it depends on how you want to do it, but either way you will end up -3 + 4 or -1 + 1 with a 1 over there. And here you can just say, oh yay, it's a u sub, where eventually you'll get 1 over u du, because plugging this guy in, those cancel. Ha. Plus, has anybody seen that we should maybe rewrite this guy just a little bit as a square root of something? I'm guessing minus x squared minus 4x. Do you see why I rewrote it the way I did? There's a negative in front of the x squared. Whenever we're doing quadratics, it's the x squared and then the constant piece. But I pulled the minus out because a squared minus u squared is exactly what I want. I'm going to do what Ale said, which was take the middle term, -4, cut it in half, 2, square it. That's going to be 4. But why am I going to add 4 on the outside if I'm adding 4 here? What is it actually? A -4, so I need a +4 to offset, but that's okay because that's exactly what I need. Now I can go ahead and say, oh, hey, this is the same thing as 1 over the square root of a squared minus u squared. Okay, hold on. A is equal to 2, right, from a squared minus, I don't know why I put minus, lo siento. U is equal to, by factor, won't that be x minus 2 squared? And then du is just equal to dx. Perfect. A squared minus u squared times du. Now here's the struggle. Can I technically call them both u if they're equal to two different things? Not technically. So I guess to be super correct, I'm going to make that a v and make that a dv and then do v squared and then do dv. Okay, whatever. They're two different letters, but it's the same thing. We're substituting. So now we end up with ln of u, who was u, 4x minus x squared, which can be positive or negative depending on the x's. So I better leave my absolute value bars. They are not redundant. And then I have plus, that's just arc sine. Remember, arc sine has no 1 over a. I need u, okay, whatever, v over a plus. Excellent questions, guys. Way to pick out some tricky ones. AJ, go ahead. Question. Oh, I didn't even see the square root. I mean, I should have because I was doing arc sine, right? Thanks, AJ. So it's not that the ln was wrong according to what I wrote, but what I wrote was wrong because I did 1 over u when it should have been u to the -1/2. So that's u to the -1/2, so we'd have u to the +1/2 times 2, so that'd be 2 square root of... Wow, that was a different answer. Ooh. It's dangerous when you leave stuff out. There's a lesson with that too. Okay, thanks, good. Now are we good? Okay. Kiddos, I'm not going to actually make you write down anything from this integration is net. Well, yeah, I'm not going to make you guys write anything down. I'm debating whether I want to talk about this at all. I think I do just a little bit just because test corrections are due next Friday, but I'm not going to do it for long. I'm not going to make you guys write down a forever card. Instead, let's go find like a quick example. Do I have a quick example? That's a long example. That's a long example. Okay, let's just do this. If you want, you could pull out your chapter 4A tests and look at question number 8, the multiple choice question 8. Everything else on that test, I am fully confident that we have stuff in our notes, in our homework spirals, in the videos to help you with, except for number 8. Now, if you understood the idea of integration and integration applied, you would have been fine. Which is why I gave a lot of you half credit if you missed. Isn't number 8 the last multiple choice with words? I gave almost everyone at least half credit because I'm like, well, you did an integral with something with an R. That was pretty much all the multiple choice answers. Anyway, I was really nice and gave everyone pretty much half credit on that one if you missed it. But I just want to talk through really quickly this idea of integration as net change. Net change, overall effect, overall effect. S of B is technically like our final position. We're going to make this a forever card when we start the next section, the next chapter, etc. But that's going to be next Thursday, so since the corrections are due early. Guys, don't we know that an integral can give us displacement? Wasn't that something we talked about last chapter? Integral is displacement. Displacement is equal to the the definite integral from a to b of velocity. What I might not have shown you super specifically is that's the exact same thing as the final position minus the initial position. There are different ways of showing that if you took a physics course, but final position minus initial position, displacement. So we can generalize because not all application problems are specifically velocity, position, acceleration. We can have just some rate of change. Now, what was it going on at number 8? I gave you an equation for rate of what? Rate of tank filling or something? Or gallons or people or what was going on? A country consumes oil at a rate of. They could have done anything. Because remember, we talked about how everything is moving, everything is changing from from finances, money to stuff spilling to gravel being processed to snow falling to everything's moving, everything's changing. So they gave us a rate. The rate could have gone in the velocity spot or the rate could have gone in the integral because wait, what were they asking? The rate of oil consumption, and then down later they're asking for how many gallons, aren't they? How do you go from rate, gallons per hour? Was it per hour? Was it per year? Per year. How do you go from gallons per year or from rate, like feet per second, velocity, to original amount or number of gallons or like position? Don't we have to take an integral? So here's the idea. The same way that it tells us an overall change in position, guess what? An integral of the consumption will tell us the change of how many gallons of oil they consume during that time period. Does that kind of make sense? And so if we wanted to ever know like a final position, like where something ended up at, we'd have to know where it started from and then the change that occurred, which will always be the integral of the rate. If we want to know a final amount or an amount at, we can always say, well, how much did you start with plus how much change occurred, which would come from the integral of the rate. So however you cut it, whatever you're doing, whether you're doing motion or whether you're doing just movement in some other context, we always integrate the rate to figure out the change, and we add it to the initial. All it is a rearrangement of FTC. Okay. Anyway, all that to say, what was the final answer on number 8? Does it make a little bit more sense? How do I get to change in? I take the integral of rate, aka the integral from a to b of r of t dt. All right, cool kids. With that, what do you have in front of you that I gave you today? A practice test. When is that due? The day of the test, next Wednesday for bonus. I'll get it on Google Classroom today, hopefully. But what else do you have on your homework sheet in Google Classroom? The book review, like always. Are we okay? What are we going to do this weekend? Review, play, study our formulas. Because as soon as you know your formulas, how many? And then the more that you practice, who are my yous, who are my do yous, what should I do, the quicker we can be as well. Bye, cool kids. I'll be here for a bit. I don't know, during lunch period, 7 after school if you need me. Happy Friday. Excellent job. See you guys later.